best photographs I've seen other people do. Clearly with, more gear, more time, more preparation, if I really spent my time focused. Whatever, and then it would have really been a no-brainer. And the other thing that I probably should have done ahead of time is set the camera up for bracketing. If you're not familiar with that term, what bracketing does is when you push the button to take a picture, with bracketing enabled, it'll actually take 3 to 5 pictures, but every picture will get a different set of settings to basically move from maybe a lower aperture to a higher aperture, so that basically you capture more of the same images at different settings, and then you can compress those in Lightroom and do some post-processing to really beef up your high definition, or get that broad spectrum of light in your images. So those are kind of the two things I wish I would have had a little bit more time to set up and get familiar with. But yeah, digital timer and doing bracketing. And I do plenty of other stuff where I use those things, but just didn't dawn on me. And at the last minute, I wasn't going to change my routine because I didn't want to screw up everything. Anything that I really screwed up was like, no. Oh, one other thing that came in super useful is I took all the batteries out of my gizmos. And so even the battery in the camera is one of these guys. So, and you can get these for pretty much any type of camera. This is a dummy battery that basically just replaces where the battery goes with USB power. This is from my APS-C, which is a smaller camera, so it works on 5 volts just fine. This one needs 8 volts. So I plug this guy into USB-C, and then it has a step in a power converter to basically deliver 8 volts to this battery, to this camera. So these specialized cables, these are all available on Amazon, $8 to $15, something like that. And then the Ninja V just uses a standard 12-volt battery. And I plugged all these guys into this turkey, which is a Blue Eddy EVB or EB3A. So this is like the kind of the king of what's on sale on Amazon right now. And you get about I'd say 275, somewhere between 270 and 300 amp hours. But the key thing here is it's got DC out. It's also got a cigarette lighter, 3 USB ports, and it also do like your traditional ports there. But what was king about this guy, or what was key, is that when you turn it on, it stays on. A lot of battery packs like this have like auto off features, and these guys don't draw enough power to basically convince this thing that it needs to stay on. Or this one worked fine, but the other ones that I went through, so I went through like 3 other ones where I was testing this stuff, and that would all just turn off after 5 minutes of being on, and it's because the battery thought it knew better, so it just turned itself off. So in any case, that's the setup, that's the gear. It was a ton of fun. This is a Wi-Fi enabled device. It also has a USB plug, so at some point in the future, I will be cabling it directly to a PC. You can probably do some more creative stuff instead of having to work through an app, but the app was super easy to do. When you first align it, it basically has full step-by-step pointed at this, put Polaris in the reticle at this point, and now it'll kind of drive you to some other star that's supposed to be visible in your area, and you align that. So you do like 2 or 3 alignments to get it really dialed in. And then after that, you've got the entire catalog, everything in the phone. You're just like, oh, I want to look at this thing tonight. And it just turns and does it. So it's pretty cool. I love it. It's a lot of fun. Questions?
So that's actually one of the things I was going to ask you about was registration. I mean, it doesn't know your lat long, basically, but it knows you're in the Northern Hemisphere.
The phone does your GPS, and it calculates exactly where you need to point things to.
Oh, okay. So as good as your GPS is, it'll get that. All right.
Yeah. And, as long as you learn how to find the North Star, right? So if you look at the Big Dipper, you take 2 stars of the Big Dipper and you align those, it'll point you right at Polaris. So if you know that golden rule, then you really don't even need that, because you just find it and dial it in yourself.
Okay.
And for daytime, star and moon tracking, you just have to, you're good enough pointing it at magnetic north, so it doesn't even have to be that accurately, aligned. So, but those things you can also do with your regular old compass, or I can't get my phone compass to point north. Like, that's the weirdest thing ever. So I don't rely on that for this. But yeah, that was it. That cool gadget. Was a lot of fun. Made for a lot of good talking points. And a lot of people showed up with some really expensive gear, big telescopes, and we're doing things that were beyond my skill set and my knowledge of astrophotography. But walking into this blind as a newbie, I couldn't be happier with what I walked away with.
Thanks, Chris. Very interesting.
Yeah, thanks, Chris.
All right. Next.
So Elliot, should we put Elliot on? Elliot's got some slides.
Sure. Yep.
Yes, sir.
Francisco, we'll probably put you on after Elliot. Okay. Is that okay, Francisco?
Yeah, I think it's fine. Can you hear us fine, by the way?
Yep.
You're good.
Okay, cool. Let me just turn it up a little. Sure. Let me see if I can share my screen. So it shouldn't be too much. To employ a power limit and a cost limit, as well as just we have some more limitations just to make it easier for others. And as is in the name, single board cluster competition, the aim is not to use full nodes that you would see in a data center, but instead something that is easier to find, like an Orange Pi, a Raspberry Pi, a Rock Pi. These that are like commercially available to people. So last year, what we used just to benchmark and grade was just the typical HPL, right? The high performance lean pack, also HPCG, which up to this year were like standards for the student cluster competition at the SE conference. Actually, it's a little bit of trivia. HPCG has been swapped for MLPerf, the machine learning benchmark. So it's kind of interesting to see a change in that. But anyways, some other stuff we had was the Intel MPI benchmarks, just to measure just like the network aspect. And especially if you have a lot of single boards, it's something that incentivizes students to have multiple just boards. And then the final one was Graph 500, which was based on creativity, just see what implementation students come up with. So this was last year, and the students that participated came from UCSD, so that's our school, Aalborg Universitet, which is in Denmark, and Pasadena City College. And we held it here at UCSD, and it was kind of a one-day event to just see if we could chug everything out. It was overall a lot of fun too, especially because we got to have everyone hosted here in person. Now, this year we have been organizing something very similar. This year we're having our team, Aalborg Universitet, which again from Denmark, and will be participating remotely. UT Austin, or people from Texas Advanced Computing Center, who are here and helping us organize again in person, and students from University of Kansas. Now, the students from University of Kansas, they participated at the student cluster competition, and for them, just it's also a way to just further their skills in HPC. And this year, it's kind of the rules that very similar to the rules that we get most years or last year, since last year was our first year, which is a 250-watt limit, which usually keeps the cost down. A $6,000 limit just for total amount of hardware and resources. A minimum of 4 sockets and to be able to run MPI just to make sure that people are being in a cluster. Then again, some more specific rules like no M1, M2, or M3 chips. Yeah, we also try to aim for participating physically, so in person, and we gave a limit of 8 max students per team. And also this year we're employing a no accessing the cluster, which even though that does setting up remote access is a feature of most HPC clusters, also with scheduling and how programs or applications are supposed to run after each other and so they don't conflict. So, all right. This year we're also splitting up. We're dividing. We're still keeping HPL and HPCG, but we switched out our Intel MPI for a Cube 20. This was actually suggested by Kurt Cavill to Benjamin Lee, who is helping. Who's actually I believe he's here and he's helping organize this as well. And we're also keeping a mystery app just to see how well students know their cluster and are able to add another application on the spot. Okay. Yeah, we're splitting up into 3 days. So Thursday, tomorrow will be our first day. And actually, this is why you see a lot of us setting up the room today. And that's why we have our camera as just us setting up some stuff. Tomorrow will be where they can come in, set up their hardware, make sure that everything works, maybe do some testing. And Friday will be the first day, which will be the benchmarking and making sure that they can give some results as what their cluster is for HPL and HPCG. And around midday, around like 12 p.m., we plan on releasing what sort of problems we want them to solve for the Cube 20. Again, that's the Rubik's solver and also the mystery application that we have. And then after that, they'll have the rest of the working hours of that day and the following day up until 3 to submit their applications. And at 2 hours after that, we plan to give them a few tours around UCSD, the campus, and our Expand supercomputer. And 2 hours after that, at 5 p.m., give them the results. So yeah, that's pretty much a quick summary of it. I appreciate your time. Are there any questions?
So are you going to make this? Is this going to be an annual event, Francisco? And is it always going to be the same time of the year?
Well, hopefully, we'd like it to be. I mean, it's a way for groups that cannot afford the process of going to SEC or maybe even indie SEC to just get more into just high performance computing in general. So we'd like it to be that. This is the second year, and our mentor Mary has been pushing for a student-led program like this or competition for a while now. So it actually, I guess as a plug, if you know any group that might be interested, then this would be a good thing to, it would be helpful if you could contact us at some point after that. Either me or Benjamin Lee or someone similar, maybe even Kurt. I'm sure he can forward you my contact info.
Absolutely. Okay. Anyone else, or should we pass off to Elliot?
Okay. Well, thank you.
Thanks, Francisco. right. So can I take over screen sharing? Let me see. All right, how does that look, folks?
That's good.
Okay.
Good.
I'm having enough technical difficulty. I'm not going to try and make this complicated. Okay, so I didn't have a chance to de-enterprise these slides, so to speak. So bear with me. I'll try and have a little bit of fun with them. I'm going to recap GTC, which was has historically been NVIDIA's developers conference. Stands for GPU Technology Conference. As you might imagine, there's a lot more AI there than there was in previous years. It was really interesting, really exciting. A lot of, I don't know, a lot of buzz, a lot of excitement. Everyone thinking about what AI can do and the technology that's enabling it. So this is a photo of NVIDIA CEO Jensen Huang. On the left-hand side, you see the new chip, and on the right-hand side, you see the existing chip, which is the H100. So you can see that chip on the right, the H100, is about half the size, give or take, of the new Blackwell chip on the left side. NVIDIA, I guess, is famous at this point for building very large chips, basically reticle size chips, the largest chip that can be built kind of all in one. And what's unique about Blackwell, and I can talk a little bit about that, is basically two of them being stitched together. So again, the kind of the biggest, most powerful chip that can be put on a die like that. It's worth mentioning that NVIDIA is very well known for GPUs, but on the bottom you'll see there's an NVIDIA GPU, there's an NVIDIA DPU, which is combining networking, basically building an ARM CPU into a network card. So you have networking, data path, along with ARM cores that can work with the data as it flows. And then NVIDIA has also built a CPU, and a lot of that is all coming together now. So known for hardware, but also a lot of software work. A lot of what NVIDIA does is actually the software, not the hardware. CUDA is maybe the most well-known, the most long-standing, but NVIDIA is building libraries for all these things along the top. So accelerated computing libraries for data processing, which is pretty general purpose. A lot of engineering applications, which are a little more special purpose. Computer-aided drug design, even more specific. That is both kind of traditional simulation techniques as well as a lot of new AI now. There's a lot of excitement in life sciences because biology is such a complex process that AI is going to enable an ability to understand and reason about biology in a way that we just haven't been able to crack through our own brain power and sweat. Similar in climate simulation, like 5 order of magnitude speedups by using AI methods, some of the deep learning methods instead of traditional simulation techniques. Kind of some similar stories in quantum, really interesting activities in robotics where people are training robots in virtual worlds before they operate in the real world, right? So you can have a robot try something and fall down like 1,000,000 times before it learns how to do it the right way. It'd be very expensive to do that in the real world. You can do it in a day in a virtual environment. So the robots learn how to move around in an environment that they believe is real, that's kind of virtually rendered real. Available to get later this year. But coming along with that is a version that is tied to a CPU. So you have an ARM CPU and an NVIDIA GPU glued together. They're coherent so that the GPU can read the CPU's memory and vice versa at a much higher speed than is possible with some of the older style configs where you have a GPU card and you plug it into a PCI Express slot. That works. It's getting faster generation after generation, but this is like 7 times faster than the PCI Express connected GPUs. So anything you see GH or GB is CPU and GPU tied together. And then fabric to connect all of that. And that has been a big deal in HPC, right? We have high-speed fabrics. We've been doing that since the beginning of supercomputing. difference being that it turns out AI needs even higher levels of connectivity. So you might have one 400 gig link in your supercomputer to each node. But if it's an AI supercomputer, you probably have 8, 10, 12 400 gig links to every single node. It's kind of wild. I'm going to jump around a little bit. So the new chip, you can kind of see there's 2 dies glued together. And there is a 10 terabyte per second link between the 2 dies. And then there are also really high speed links to these gold things on the top and the bottom, which are HBM memory. So it's 192 gigs of memory on the Blackwell. You basically use this as if it's a single GPU. And you're getting 10 petaflops of FP8, which is used a lot for AI training. And potentially FP4 as well for training. So you can build AIs at a very, let's see, you need the memory capacity to hold a larger model. And you also need both the memory performance and the compute performance to go along with that. So you load all of the parameters into memory, and then you can iterate on them very rapidly. If you look at this chart, you can see the performance for 175 billion parameter model, which is actually relatively small. GPT-4 is guessed to be like 1.8 trillion, so about 10 times this. And you can see kind of generation over generation, the performance of the various chips to run inference on this relatively small model. The larger the models get, the harder it is to fit them in any system. And so you have to fit them to start, which needs the memory, and then you have to iterate on them both as you're training as as you're inferencing. Let's see. Let me jump down to this. This is the new big system that's being built, which has 2 Blackwell chips plus a Grace CPU all connected, and those essentially go into a backplane. So this board, 2 of these boards are loaded into a 1U tray. And then they're connected by super high speed NVLink. If you saw on the previous slide, Fabric is 400 gig right now, going to 800 gig, and that's gigabits, right? 400 gigabits, 800 gigabits. NVLink is 900 gigabytes per second. So we're talking an order of magnitude increase in the throughput of the fabric that connects the GPUs. And that's built up into this rack. It's a single rack that can hold a 27 trillion parameter model, which is essentially 10 plus X larger than GPT-4. It's not really known exactly, right? A lot of this stuff is not released yet, but the scaling laws have largely held that the more parameters you put into an AI, the more capability it has. So getting another 10X capability in AI model size is going to be very interesting to see what people do with that. So this is one rack, 120 kilowatts. A lot of standard server racks, not that long ago, were 10 kW. This is 12x that. So all liquid cooled, 120 kilowatts. It's pretty hard to get that into most data centers. Massachusetts is a green data center, MGHPCC, which all the universities have collaborated on. So Massachusetts, it will be possible to run one of these, but it is generally difficult to do so. And so there's a few other things, right? If you can't do the 120 kW rack, you can do a slightly smaller version. These are under 20 kW. And then there's a version that fits all the way on the right here that fits kind of the existing form factor. Perhaps maybe I'll share one more thing, which is the idea of microservices, which is I think a little bit, maybe very common in enterprise commercial. You think about cloud providers having quote unquote serverless services, things like that.
George.
The difference being
George, faster. I'm not going to be closing, so let's go faster.
Sorry, there's some background noise. So the idea here is that increasingly folks are going to build AI inferencing into all kinds of different things, certainly chatbots and things like that, right? But also scientific workflows where they might be calling an LLM to work with textual data, but perhaps also a visual model, and perhaps also working with genetic data, protein data, mathematical data. There's a lot of work just come out in the last few months where folks are training the equivalent of ChatGPT only on DNA, right? So there's no human text, it's just DNA text essentially, and they're promising results coming out of that you train it on just DNA and it can work with RNA, it can work with proteins. So there are going to be scientific applications making chatbot calls, if you want to think about that, and that's essentially inferencing. So you'll be able to, from your Python code, Python notebook, make calls into AIs, whether it's calling it for text summarization or text generation, calling it for coding, calling it for DNA, molecular type applications. And there's some folks building quote unquote foundation models for science too, where you might be calling an AI to work with your data. And so you can play around with this. You can go to ai.nvidia.com, try out a whole bunch of different models. We're building standard APIs so that you can easily flip out your models. As new AI models are released, you'll be able to use the same API calls to call the new better models and be able to, build your various projects around all of those things. I think that's it. I'd welcome questions.
Were you out there for GTC?
I
Elliot?
was, yes, I was, and I'll share a link. So there's a whole keynote with all kinds of fun stuff. But if you watch that link on YouTube, you can see kind of all of this coming together, where they show you the chip, and then the chips come together, and the NV switch comes in, and you kind of get the full thing. What I've described here is probably only a tenth of everything that was talked about at the conference. There was so much going on. So yeah.
Yeah, I sat in virtually, and yeah, there was a lot of NVIDIA adjacent stuff going on this year too. We had swapped an email about some of the Micron announcements. That pretty fascinating stuff.
Yes,
yeah, and I had Google Trends and Google Zeitgeist open during GTC, and who was Blackwell was the lead search.
Yes, there is more than one Blackwell. There was a woman. I think she was in medical sciences. But the official name is for David Blackwell, who was a mathematician. And I'm embarrassed to say I did not know David before this, so I need to spend more time looking at his bio.
Well, it doesn't roll off the tongue like Volta and Ampere, and and for that matter, Tesla and yeah.
I think there's an effort to recognize scientists and thinkers that haven't been as often recognized, which I'm glad for. Like Grace Hopper, for example, she's probably better known than David Blackwell, but it's good to I think remind ourselves of some of those stories. Yeah, a lot of people came before us.
Yeah. Any the ones that you attended? Any particular things stand out for the lectures you attended?
Yeah, good question. Well, I guess I kind of touched on robotics, but there is generally an impression among researchers that suddenly we're seeing new things. Robotic research has been chugging along for decades, right? But some of these new methods where they can develop robotics virtually before bringing them into the real world seems like that's really speeding up the pace of iteration and the expectation that there's going to be more useful robotics systems in the real world fairly shortly. Dr. Panda from Ohio State was there. They're still cranking along on this kind of merger of networking and computing, and the more computing that happens in the network, the more interesting efficiencies and optimizations you can do. So they were talking about that. In general, the Grace Hopper thing is very interesting. The combination of the CPU and the GPU together is unlocking some interesting things. So there are quite a few talks about that. There are a number of supercomputers that have already been announced, both in Europe and in the US, and I think maybe in Japan as well. Some of them fairly substantial. ULIC has a big system coming online that has an NVIDIA CPU and an NVIDIA GPU. Power efficiency, is a big part of that. It's much more power efficient than an x86 based platform, but the linkage of the memories allows for some very interesting capabilities as well, both from a traditional HPC, simulation and modeling perspective, but certainly from an AI perspective as well. As these AI models get larger and larger, it's hard to fit them in memory.
Yeah, I think there's some companies that are trying to move the what do you call that, Bill? The Overton window, like Microsoft saying that they need a $100 billion data center.
I did see that.
So
yeah, AI is very capable, but current AI models are not as power efficient as the human brain. They may become more capable than the human brain from a intelligence output perspective, but they need a lot of electrons moving through them to get their work done.
Yep. Yeah, I don't even know how you build a one. So like you say, even when you're next to a river in Western Massachusetts, 120, what'd you say, 120 kilowatt per rack?
Yes, correct.
Okay, so I don't know how you do that with, we'll have to bring an electrician in on our next discussion.
What-
I mean, what is the code for that?
MGHPCC is at, I think they're already at 20 megawatts, give or take, right? So 20 million watts already with headroom for more. So they can't do this thing that Microsoft is talking about, but they and I was talking to some folks earlier today, and they can do some of these racks if that's what they decide to do.
Wow.
They're already doing, I think they've got 60 kW racks already running there with already clear ability to do 100, I guess. So 120 isn't pushing it too much further. It is kind of wild, but some of the big supercomputer sites have been doing this for a while. Kind of the old Cray style, now HPE Cray. They've been doing kind of full liquid cooling for a few generations now. So my understanding is it sounds wild to some, but there are already some centers that have been doing this for a little bit.
Yeah, more a pod, right? So this would be a couple of racks, or is that a single rack?
The 120 is a single rack, so you can do it as a single rack. If you watch the YouTube link I showed, the video shows it going to 32,000 GPUs, which is like a whole field of racks. So that's what the the Microsofts of the world are probably going to look like.
Wow.
Yeah.
Okay. Anybody else? Anybody else got any questions for Elliot? I think you've got a lot of lurkers on the
Yeah. Well, that's cool.
the YouTube
And
channel.
the lights just turned off here, so I can lurk too. Thanks for the Eclipse talk, by the way. I made it to Maine for that, and it really is a unique experience. I recommend it.
Yeah.
Okay, you need to pay your bills.
The Wi-Fi's still on. I'm good. I don't need photons. At least visible photons.
I sometimes get that at the library where I hold my Toastmasters meetings. They're the room we meet in has the lights on motion sensors.
Yeah.
So whenever they go out like that, I just wave my hand in the air a little bit and it comes back on.
Thanks, Al.
Okay. I think we're going to pivot to David Lee. We've got a couple of student cluster contest talks, like really quick ones, just sort of status updates. I think me and Josh is here from Wentworth. I think him and I will probably talk about some of the competitions we're involved with as well. I have, if we have some speakers after David, and we might have the UCSD folks talk again once we start talking about student cluster contests. So, but if you want, David, you can bring us up to speed on your research. I've got some research to discuss with you too. Like I say, I saw some pretty amazing Micron demonstrations at GTC. I wasn't out there, but they did about 25% or thereabouts of the content was streamed. It was virtual, so that worked out great. But yeah, David, if you have any updates, feel free to fill us in.
Oh yeah. Let me just share a quick presentation. It's short, but it's just the small stuff that we've been working on today or this semester. Yeah, let me just get that. Ooh, can you guys see that? Is that good?
Yep.
Okay. So what we've been preparing for this whole semester, really, we haven't had many general meetings just because unfortunately all of our e-board members have been swamped with work. It's like that kind of season for us, but we're hoping, and we've been planning this throughout the semester, the return of Massachusetts Green Team, featuring Yours Only BU and Northeastern University. So a bit ago, I reached out back to Professor David Cayley to see if he was willing to have some of his students come help us out for the competition for SC24. And he's had two brilliant volunteers who I'll show later, who will be joining us on our team. So hopefully our process of applying for the competition and just preparing goes well, and fingers crossed that we get in so we can have another successful or even more successful year than we did last year. And I believe I gave a spiel about this back in November, so I'm not going to talk that much about it. But this is just some recent history of HPC at SC. So that was that. So we've actually been consistently getting in every year, which is pretty nice. But I guess I'd just like to quickly talk about our recent showing on SC23. And we actually had a blog posted from BU about our competition. So it went pretty well. We didn't get last. I think we performed better than we thought we did, given our limitations and not just our team, because our team wasn't as experienced as it usually has been in the previous times. But we learned a lot from it, and we did have a lot of complications with hardware. So in the image to the far right, the third one, that was our computer cluster, and it was in a shipment container. But we managed to actually get hold of that, I think 36 hours after the competition had officially started, because it was stuck somewhere in an Ampere booth. And they didn't let us, I don't know, it was a really hard thing, and we were really stressed about that, but we did get our computer. Had a lot of great time and learned a lot. That's the most important thing. So as for our team, this is the current roster that we have prepared. So Shamra and me, will be our second time competing, and we'll have 4 new members. That is Jason Jiang, who's our current treasurer. He is the youngest on our team. He's actually a sophomore right now. And Emeka, who is our cluster manager. And we have Hamza and Xander from Northeastern University, and they're both ECE. One thing to quickly note is all of us are engineers, and I think that's the first time that everyone on our team are actually engineering majors, and we don't have any computer science majors. So that's that. And in terms of preparation for it, so we've been in contact, and weekly meetings have been held for our team, and we've just kind of been discussing general ideas about how we should proceed with this, because last year we felt like planning, or at least Shamar and I felt like planning was a little more over the place. So this time around, we're kind of centralizing it more with the weekly meetings and making sure our application is fully fleshed out before we, start with hardware preparation. But in terms of hardware preparation, we have been fiddling with our home-built Raspberry Pi cluster, which, thanks to Ben, I know he's here for getting that all set up. But Shamar and I have been fiddling with that just to get things prepared up, and also the BU's own shared computing cluster. So that's kind of it. Not many updates, because this semester has been really kind of a drag for most of us here on eBoard. But other than that, I guess if there's any questions about how we're doing or our future plans, because that will be my last competition, feel free to shoot out to me.
So they've already had some open webinars. Is that correct, David? Where you can call in and I think they're talking about the codes that they're going to track this year.
I don't think so. Yeah, actually.
I thought there was one. Let me go see if there may have been one that they did already.
In the meantime, hey David.
Yeah.
How's it looking for the timeline? Did you guys already submit your application, or waiting for results, or what?
We haven't submitted the application yet. We're still in the middle of writing the prompts, but I'd like to say we're at least halfway into the prompts. The deadline is on the 15th of May, so obviously by that time we'll be way more ramped up for that submission date.
Nice. Good luck this year.
Yeah, thank you.
All right, I'll look that webinar thing up. I thought they already had one, but it would be pretty early if they've had one. When's the deadline for submission? We've got a couple months, right?
Yeah, 1 month actually. It's
1
in May
month.
15, so not even. It's like
Oh, wow.
28 days.
Okay.
Yeah, very soon.
Okay.
Hopefully it works out for us though. I'll keep everyone posted.
I think I invited some other schools and teams from previous years, because remember last time we did this, we had like basically 5 schools represented, like 1 or 2 people from each school. But I don't know if this probably didn't work out too well this month. I know Matt Chung's online, but he's not going to do SCC this year. He might do it when we get like a Team USA together for the ISC, but that may be a while. You got it? Is Matt online? Yeah, he's online.
I am putting together a team for UCR. I mean, like, we're the U.S. national team thing was for like ISC, right?
Yeah. Yeah. Oh, you are putting a UCR team together. Great.
Yeah.
You know what kind of hardware you're looking? Are you looking at AMD or Intel or any particular?
So I'm also like a solutions architect at UCR, right? So for a instructional cluster, we're buying 2 Grace Hopper nodes, which Elliot talked about earlier. And we're gonna give those a try. Obviously the like supposed like ARM power efficiency is something we want to test out to see how effective that is, and then we're going to look for obviously sponsorships, which is probably the biggest barrier to bring the actual hardware. Everyone has hardware to bring, but being able to actually bring it is a different story, due to vendor availability and GPU availability of industries and eating all of that up, so
Okay. Do we have any other student cluster contest folks online? I know Josh and I had talked about it at Wentworth, but their season, their school year is a lot different than most other colleges, so I don't know if that would line up very well for Wentworth. Anyway. Okay, moving along. Anybody want to talk before? I was going to talk about the project that Josh and I were working on at Wentworth that we were going to present this weekend, but so the conference we're running this weekend is called latchup.io if you want to look at it, latchup.io. Him and I were going to do originally a 3-way presentation. Let me see if I can figure out how to start. There we go. Start screen sharing. Dunk. See if it'll let me do this. So the original plan was we were going to do a 3-way presentation on universal binaries for multiple processors. We had a bunch of. Let me navigate down to my video here. We had a couple of use cases, and we had a little bit of prior art, and then we had division of effort. It was going to be Josh and Wentworth, myself, and then we also had a researcher at Northeastern University who would have really closed the loop with us. I'm not sure why my oh, I know why. I was looking at my Chrome tab rather than everything. There we go. Share my PowerPoint. Well, you know what I should do? It probably won't let me share PowerPoint. Let me try something different. Maybe I can just share the whole screen and then just pivot over to it. Yeah. I will pivot over to. All right. Yeah, that'll work. I think. Let me give it the old team try. Okay. Nope, screen sharing failed. Give me one more minute, guys, and I'll see if I can. I suppose I could upload it to a Google Sheet and share it from there. Start screen sharing window. Share. Yeah, I don't think it's going to let me do this. All right. Well, while I figure out if I can share this another way, I can probably pass it off to. Does anybody else have a short take? Bill, do you have a short take on any topic?
No, I wasn't going to talk tonight.
Yeah. Well, I certainly this is a nice healthy demo, or excuse me, a nice healthy presentation. I just can't seem to get Jetsy to let me share it, so I'll figure out if I can do. How else could I possibly share it? Oh, you know what I could possibly do, and you know what? This is only about the 1,000th time that we've done these conferences, and we always seem to have the same bunch of errors cropping up. Okay, let me do this. I'll try to share it. I'll see if I can diagnose. Please reload and try again. Okay, that doesn't mean anything.
Security is nice, except when it gets in the way of work.
I'm sorry?
Security is all very well and good, except when it gets in the way.
You know what I could do? I'm trying to think if I have this online somewhere that I could just give you the URL. I can certainly narrate the story, at least my part. Hold on.
I can try sharing it. What's the link?
Oh yeah, like I said, I'm pretty sure I don't have a link. Because I was developing it here on PowerPoint, and I was going to possibly upload it to G Drive or something like that if I needed to before Saturday. But we already had taken our presentations off by then. Actually, you know what, Josh? Should we talk about BossNet? Should we talk about BossNet here?
We could do that. We can talk about the hopping at maybe the next blue.
Yeah, and by then you and I will have our parts done, and our third presenter from Northeastern might as well.
Yeah, we should have some data and a demo at that.
Okay,
point.
Let's do that because we're only about we're a good couple of 3-day weekends away from having not only the presentation buttoned up but also the functional demo. Okay, well let me find let me quick and find the URL for BossNet. Now you have the PDF, right? So maybe do you want to share the PDF or should I just find the URL for the?
I don't have it on this machine right now.
Okay, let me see if I can find MIT IoTNet. Yeah, see if this resolves. Because what I will do, I can definitely display Chrome tabs. So what I'll do is this tinyurl.com and see if this will resolve to the BossNet page. It does. Okay. So let me share this, and then if we have to, we'll share that link. Okay. So sharing IoTNet. It's about this time for another good IoTNet meetup. All right. So Josh and I are so IoTNet was a not really a field test. It was more of a lab test of agnostic LoRaWAN fielding. So the way you would do an agnostic fielding, we modeled this substantially after the old MIT RoofNet project. So the RoofNet project was supposed to prove two things. they used this thing called the Amos model, which is agnostic mesh omniscient star, which is to say that you give a bunch of free computers to students. And back then, so this is 10, 15 years ago, it was a computer. They said, here's a computer, here's a 12 dBi omnidirectional antenna, stick it in your window. And the good news is, like, why would you do this? The good news is you get free MIT bandwidth if you do this. And 10 and 15 years ago, that was a pretty compelling story. The student would say, great, I will live, 2 kilometers off campus. Like as you can see there, it's a little strip map of Boston with one of the nodes in it and the coverage area. I mean, the ideal coverage area. Certainly, Bill can tell you, you never get a true circle with an omnidirectional antenna. But the quid pro quo was the developers of RoofNet could log on to your computer while you were at school, and then you could do anything you wanted with it at night. And back then, I mean, you were getting as much as you could get out of this. This is before 11A, and it was probably before 11G. Anyway, you were getting 10 megabits per second. Let's say 11 megabits per second, which was damn good back then for free. You could stream video for the sites that were doing that back then. It was a great deal. So everybody that was within range of the big, powerful 22 dB omnidirectional antenna on the top of building 32 could set up one of these RoofNet nodes, talk to the centralized node, the aggregator. They called them sinks. I know RoofNet had different terms for everything, and you'd be able to then get, if you were in a really good location, a single hop drop back into the internet. Now, the whole part with this research project was, why don't we give these things away for free? And if people don't have direct line of sight to the top of the Green Building or Building 32 at MIT, they will be able to hop via this algorithm that they came up with and published. I mean, that was what the research was for, was to find this ad hoc wireless mesh network thing where you just gave everybody who wanted bandwidth free computers, and they just put them in their window. That was the level of install that was expected from this program. And they to a great extent managed to get to that level. So what we did as an add-on to that was we came out with IoTNet, which would allow you to then put these LoRaWAN nodes, much in the same fashion, much in the same Amos fielding technique, to then get LoRaWAN capability. The difference with this model is, you didn't have a PC sitting in your window on house current. The LoRaWAN nodes were much less power. They were either like most of the time when you buy a LoRaWAN node, it's on like a 12-volt SBC or something. The ones we were looking at had a button cell in them. Remember, you used to be able to buy these buttons from Amazon where you could order Dash soap. They were just called the Do It button or whatever. So we put a lot of these LoRaWAN transceivers in there, and they'd run off of the 3.3 or 5 volt button cells. So last year, Josh and I said, okay, well, let's take this to the next logical extension, which is bandwidth anywhere in Boston whenever you need it. What you would do is you're walking around town. The usage case we demoed for IoTNet was you're walking over close to a red line stop, and because you're on LoRaWAN and because of the physics of the LoRaWAN protocol and the radio capabilities, you'd be within range. It would know it. It would say, okay, this guy's 5 minutes from the T station, probably 30 minutes from getting home, so let's turn up his Nest thermostat. So the way you would do all that glue code now, so that particular proof of concept was intended to demonstrate the passive nature of this model. you would have a LoRaWAN dongle. By this point, here again, we haven't done this yet. All we've done is lab tests with a little bit of field testing, but we didn't totally trick out a network. You would have some sort of dongle with LoRa radio on it. It would probably be on your keychain, and then whenever you walked by a LoRa device, you'd be able to get a couple of location-based services out of it. And one of those, that exact tortured demo I told you about, someone actually did that. There's a website called If This Then That, ifttt.org. So what you do is you set up a trigger, and you set up an event, and all the plumbing in between is handled by things like this network, which is to say that you register your MAC address with the Things network, and you get into your dashboard and you set up all these connections, and from then on out, everything theoretically will be passive. And I think that's what Josh and I want to do with BossNet, because if we can glue this sort of dog's breakfast of RF that we now have still functioning and still free in Cambridge and Boston. Plenty of RoofNet nodes out there that the city of Cambridge have installed, and they're not using them so much for the Cambridge public internet anymore, which probably peaked a decade ago, but they're still functional. The outdoor nodes in nice watertight NEMA boxes with 12 dBi antennas, they're not all working, but some of them are. And then there's many other things that we can get sort of bandwidth from previous incarnations of this. I think it was called the Ricochet Network. Does nice little dish antennas. We can get some bandwidth out of those. But we'd have to install all of this LoRaWAN. It's quite possible that there is a large LoRaWAN network out there that we haven't tapped into yet, because since about 5 years ago, all the new Comcast modems have LoRaWAN built in. So if you've gotten a Verizon service, Xfinity, Xfinity is Verizon, right? Well,
no, vice versa.
Okay.
Xfinity is craptastic.
Okay, so if you've gotten a new cable modem in the last 5 years, if you've got new service and they did some on-premise equipment at your house, it's got a LoRaWAN chip in it. Now they haven't turned it on yet. I don't think they see the business model. Maybe we could convince them that this would be a great university test bed. That's kind of what Josh and I have been pitching.
Yeah, that's correct. Surprisingly, a large amount of the IoT consumer home devices actually have some level of connectivity that is not being used. So if we can have a crossover, we should have a pretty decent and robust mesh network.
Yep. I think so. We have written a couple of papers, and we have applied to a couple of conferences. Now we haven't applied for grants yet, and we may not need them. This gear is pretty cheap. We own quite a bit of stuff. It just needs to be disassembled, reassembled, probably soldered. It may make for a couple of hackathons, but I think we could probably
field. Because you need to do the grants first.
Yeah, absolutely. Yeah. Or, well, we were hoping to get the grants after our first paper, but we haven't gotten a paper accepted yet.
Yeah, we'll probably be doing one of the Linux Foundation mentorships, though, over the summer as well, which has some amount of funding associated with it.
Okay, this is weird. It says I'm not sharing a screen. Okay, so if you guys did not see anything, which quite possibly you did not, I'm going to drop the URL into the chat window right now. So, like I say, it's very hard for to do real time updates.
Yeah, there was a shared screen that showed up, but I had it in tic-tac-toe mode, so couldn't read it.
Okay, it must have fallen off. Okay, well, let me drop So I do have a URL I could drop in the chat window here, and this has a little bit of the history of IoTNet, which now I know that you can't really put the word net next to IoT. They get the word net twice, but anyway, it was available on the tiny URL. It's URLs or extensions never expire on tinyurl.com as long as it's been around. I've got stuff in there that works. I think they've been around since the 90s, and some of these old redirector they're still functional. I'm trying to think of the oldest one I've got. I probably have something from anyway for another discussion. Yeah, so Josh, after the dust settles on LatchUp, we should see if we could talk to somebody about opportunistic routing. You know, and correct me if I'm wrong here, Bill, the FCC doesn't really care what you do with a lot of bandwidth under certain power ratings. Like you can buy a product that uses, say, WBZ's spectrum, or 1030 megahertz or whatever, as long as it's like under like 100 milliwatts, you could probably broadcast off of that frequency in your kitchen.
Well,
Didn't that?
If you interfere, you're screwed.
Yes.
So where you are does matter.
Okay. So it's not strictly a power issue. It's probably a gain issue, huh?
If you go into reserved radio astronomy or Air Force frequencies with 100 milliwatts, you may get visited.
Okay. All right. We won't do that.
So it's more complicated. If you've got a Part 15 device and you're operating it at Part 15 power levels and Part 15 I'm back.
Okay, well that's all I've got. If there's anybody else, feel free to chime in.
So is that it for all the student works? Student presentations?
Yeah, we had some cancellations. I thought we were going to go right up to 9, but we had some cancellations. So this looks like all the content we have tonight.
Okay. Did you say earlier that you might be able to do some more talks up in the near future?
Yeah, let me look at the you've got a couple people booked for the next couple months, right? I think we need at least a month to get Josh and I want to put a pretty good package together. That'll take us at least a month, maybe more.
If this right now, we have no one booked unless Christoph's able to do it in less than a month.
Oh, for next month?
Yeah.
All right. Might be time for all right, we should ping DeLacy too. Doesn't he have something? I'll go find out.
Okay, well.
All right. Well, thanks, guys. Thanks for the California. Yeah, thanks for the Californians. We should maybe we'll do an SEC kind of like mega meetup on a regular basis.
Oh yeah, that'd be great. Thanks, Gert. Thanks, Gert. Oh, you mentioned something about doing another IoT fest.
Yeah, historically we did those in January, but I'll get with the usual suspects and see if we can do another one. Like the summer would be a good time for that, I suppose.
If you want to do stuff outdoors, yeah.
Yeah, okay. So you guys know there's a Swap Fest Sunday, right? The first Swap Fest of the year. I'll drop that URL in there.
Somehow it's the week after the marathon instead of the day before this year.
Yeah.
The one year that the method of calculation is different.
They have an announcement on the MIT calendar that says this is the only place that you can buy a VGA cable and an Enigma machine. That's how they're
Yeah.
advertising the Swap Fest.
He's managed to keep the value of Enigma machines up such that it's always at gasp choke.
Oh yeah.
I remember they were much more affordable back when I couldn't afford them the first time.
Is that the Romanian ones? He's got a Romanian one, right?
Yeah, the Swiss or the Romanian are more affordable than the genuine German. Only thing I buy from him are his DVDs.
Oh
the
yeah.
Other things have too many zeros.
Let's see if I can find the.
You got to be careful with DVDs are starting to rot.
Yeah, the problem.
You mean even the commercial ones?
Specifically the commercial ones.
Ooh, that's not good.
I think it's Warner Brothers WB stuff. So all of the Supermans, copies of The Matrix, so on and so forth.
I guess it's pretty important to get them backed up before they rot. Hard drives are cheap these days.